Yeah, warm greetings to you all. It's my immense pleasure to take the lecture on the topic of basic measurements in fluid mechanics in fluids. Before getting into the topic, I just want to make sure of the objective of experimental studies. There are numerical objectives of experimental studies. The main objectives are listed over here. The very first one is they make it possible to determine the influence of various features of design and modification to them in a safe, quick, direct and relatively inexpensive manner. They provide information of a fundamental nature, usually in conjunction with the theoretical work. By this means, the theory is confirmed for extended, thereby laying the foundation for future design implements of a fundamental character. Some properties of fluids are listed over here. They are pressure, temperature, density, viscosity, thermal conductivity and specific heat. And the main fluid mechanics measurements are listed here. The first one is direct measurements, and the next one is analog methods, and the last one is flow visualization techniques. Let's discuss each of these methods in a very brief manner. The very first one is direct measurements. So direct measurements in the sense we can obtain the reading from the equipment directly, and in order to find out the solution by using some analytical formula we can able to obtain the results directly. The example for this direct measurement is wind tunnel. Wind tunnels are used for numerous investigations ranging from fundamental research to the industrial aerodynamic projects. Many wind tunnel studies aim at the determination of forces on scaled models of aircraft components, automobiles, buildings, and so on. So, by using this wind tunnel, we can able to calculate the lift and drag forces for the scaled models. So, by using the law of similitude, which is F, which is equal to half rho v squared SCN, we can able to find out the force coefficient over there. Here in this formula, where rho is density of air, where v is the velocity, S is the surface area or cross-sectional area, and Cn is force coefficient. And the second one is analog methods. The analog methods, the problems may be solved by setting up another physical system such as an electrical field for which the governing equations are of the same form as those for the problem to be solved with the corresponding boundary conditions. The solution of the original problem may be obtained experimentally from measurements on the analogous system. Some of the well-known analog methods for solving fluid flow problems are the Helisha analogy, electrolytic tank, and the surface waves in the ripple tank. So, in Helisha apparatus, we can be able to trace the flow path of the various models. And next one is flow visualization technique. So, this technique plays a vital role in the flow visualization. By applying these techniques, we can be able to find the pressure and velocity surveys also. So apart from the conventional method of experimentally investigating flow patterns by means of pressure and velocity surveys, fluid flows lend themselves to numerous viscous techniques. Some of the popularly employed flow visualization methods for fluid flow analysis are flow visualization with smoke, tuft chemical coating, interferometer, skeleton, and shadow graph. And here some of the main components of measurement systems are listed here. The very first one is the sensing element, next one is signal converter, and the last one is display. Display which is used to get the output. So let's discuss each of components in a very brief manner. The sensing element is also known as a transducer. For instance, the bulb of a mercury glass in a glass thermometer and the diaphragm in a pressure transducer are sensing elements. The transducer is in some way in contact with the quantity to be measured and produces some signal that is related to the quantity being measured. So in this figure it's been clearly given. And the next one is signal converter. The signal converter is a device which is used to convert the output from the sensing element to a desired form and feed the same to the display unit. A typical example of a signal converter is the amplifier that receives a small signal from the sensing element and make it large enough to activate the display. And the final one is display. So display is yet another vital part of a measuring system. It is here that information from the sensing element, which is converted into desired form by signal converter, is read by the experimenter. A typical example of a display system is the combination of a dial and a pointer, as in the case of a dial type pressure gauge. And next one is the performance terms. So in order to conduct the experiments in a very reliable manner, we have to adhere the following performance terms. So let's see one by one. The first one is accuracy, error, repeatability, reliability, reproductivity, range, resolution, sensitivity, dead space, threshold, lag, hysteresis. So let's discuss the parameters one by one. The accuracy of a measuring device may be defined as the extent to which the reading given by it is close to the exact value. So if I am getting the value and that value is very close to the standard value, means such a quality is known as accuracy. And next one is error. Error is the difference between the measured value and the standard value of the quantity being measured. So if I am getting any differences between these two values, means such a quality is known as such a thing is known as error. Next one is repeatability. The repeatability of an instrument is its ability to display the same reading over the long period as its sensor element is fed with the same signal. With the same input, it has to be the same output even for a long time. And next one is repeatability. Reliability. The reliability of a measuring system is the probability that it will operate such an agreeable accuracy under the conditions specified for its operation. And the next term is reproducibility. The reproducibility of a measuring device is its ability to display the same reading when it is used to measure the same quantity over a period of time, or when the quantity is measured on a number of instants. The reproducibility of a device is also termed stability of the device. The stability of the device, it can be judged from the parameter reproducibility. Next one is range. The range of the instrument is the limit between the minimum and maximum readings of the instrument which are all able to measuring by it. And next one is resolution. The resolution of an instrument is the smallest change in the quantity being measured that will produce an observable change in the reading from the instrument. Even with a small change in input, we get some reliable output. And next one is sensitivity. This is one of the vital performance terms which are all being associated to connect any experiment. The sensitivity of an instrument is a response to any change in the quantity being measured. And next one is dead space. The dead space of a measuring device is a range of values of the quantity being measured for which gives no readings. And threshold. The threshold is the minimum level of quantity that is being measured, which has to reach it before the instrument responds and gives a detectable reading. In other words, we can say it is just a dead space. It is just a dead space that occurs when an instrument is used for reading from the minimum limit of its range. The next performance term is lag. The lag of an instrument is a time interval between the time of input and the time of display of the reading. So it is nothing but a time interval between its input and the output. And the last and very important performance term is hysteresis. The hysteresis is that characteristic which makes an instrument gives different readings for the same value. So once again I repeat, it gives a different output for the same input of a measured quantity depending on whether the value has been reached by continuously increasing change or continuously decreasing the change. So these are the performance terms which are all associated with the experiments. And an experimenter, if an experimenter conducting experiment, means that he should adhere with all of these performance terms. Thank you.